Welcome. I am Thomas Dyar. I'm a product specialist here at InterSystems, focusing on AI and machine learning. And this session is called Integrated ML Updates from the Field. We're going to share some of our experience using Integrated ML over the last year since it was released in October. So I'm joined by Minoru Harita, who's a sales engineer and sales engineering manager in Japan. And the main goal of this session is to leave you with some information about how our customers are excited about using integrated ML to gain insight into their operational data in a variety of industries. I also want to share what our priorities are for future development, which should get you excited to try out integrated ML on your own data now and look forward to the future when it's going to have even more and greater functionality. So after a quick overview of what integrated ML is, I'm going to discuss our latest engagement at Greater Houston Health Connect. It's a health information exchange, a proof of concept that's still in flight, but I really think it's promising. And our experience so far will illustrate, what you might do to prepare your data as well as your organization for adding machine learning to your tool belt. Second, I'm going to profile some of our efforts in the financial services area, which InterSystems has been very active. And third, I'm going to hand over the mic to Minoru, who manages sales engineering in Japan, as I mentioned. He's going to talk about an exciting project in partnership with DataRobot and PALTAC, which is a long-term customer. And this is in the logistics and supply chain area. And the goal is to predict product demand over a whole bunch of products. So finally, I'm going to wrap things up with a quick preview of our development roadmap. And we've been really intensely focused on getting adoption and listening to our customers and working with them. So we haven't actually released any new functionality, but we've got a lot of great ideas from our customers and from our users. So I hope you're going to learn a little bit about integrated ML if you don't know much about it already. And I also hope you learn a little bit about how it's been used or how we're trying to use it in use cases across the globe. So integrated ML is a SQL facility. So a developer adds simple SQL statements you can see there in the center. In the course of their application, anywhere they can get to SQL, either through a JDBC, ODBC connection, they can use integrated ML. And the machine learning happens right where your data lives and in the same context as your data. That makes it easy if you're very focused on the data, you know what data you have, and you want to use some machine learning to get some more insight into that data. And then, as you can see on the right, we have different engines that actually do the machine learning work. That's not actually handled by SQL, of course. It requires different packages in Python and other languages, or entirely different platforms, such as DataRobot, which is a partner of ours. Okay, I'm going to show you a quick example of how you might use integrated ML, just to really kind of make it concrete. So say you have an orders view or an orders table. It's actually a view of a very perhaps complicated schema that has some information about orders and when they were fulfilled. And your problem in your business is that some of them get delayed and you have kind of random delays. You don't really understand why it's happening. But you've collected a bunch of data that you think might be related into this one view. And you have this one column delay that you want to predict. Well, to use integrated ML in this problem, this machine learning problem, first you just do a create model statement, you name it. This is kind of like creating a table. And you tell it with the predicting clause what column you're going to predict on. And then you tell it what data you're going to use. And that sets up the machine learning problem as far as what the input variables are and what the output variable is that you want to predict or you want to learn the relationship between the input columns and the output column, which is delay. No machine learning is done at that point. That happens when you do train model, and then you refer to that same model name and you tell it what order data. In this case, we're just going to send it the same order information. However, you can specify, since it's all integrated with SQL, you can use a where clause to subset the data. Then after the training is done, you can run a validate model statement, which runs the model over whatever data you give it in that statement and calculates some metrics for accuracy. Then to actually see those metrics, of course, this is all SQL, you then do a select statement from the information schema table, validation metrics. And then you can see whether or not you got a good accuracy score. Then when you actually want to use an integrated ML, use those predictions, you can use the select statement. Of course, you can get all those variables back with the star. And then you have a predict function that you just pass the name of the model. And then, of course, you can name it, delay prediction in this case, and specify what data you're going to actually send to the model. And this is the kind of output then you'd get. So you can see the original values there for delay, and then you can see the prediction. It may be exactly right, as in the case of one, or it can be just a little bit off. And typically, you're not going to get 100% accuracy out of any model. But nevertheless, you can see that this is a very simple way to take data that you have already organized and be able to run machine learning models against it. Of course, machine learning is a very complicated field, and there's plenty of different ways to do it in reality. So we've built in multiple flavors or engines that actually do the machine learning. We have a default that we call AutoML. It's really for people that just want to get going right away. There's really no knobs, and it's good for exploration and prototyping. Works on most data sets pretty well. We also have incorporated another open source provider, we call them, built on H2O AutoML. And this one has more knobs to tweak, maybe more for experts, but it has a couple drawbacks, one of which is that it ignores text columns, which our default AutoML does some processing on text. So then finally we have a DataRobot provider, and that actually calls out to the DataRobot platform, which is a market-leading proprietary platform that also provides, in addition to just training models and very sophisticated models, it also provides a UI where you can do data exploration and look at the explanations of why different predictions were made, and a lot of other functionality around managing your models using MLOps capabilities. So now we've seen what integrated ML is, and let's talk a little bit about how we're using it. The first case I want to talk about is at Greater Houston Health Connect, which is a customer of ours that stitches together the healthcare information across the Greater Houston region. There's 8 million people there in 24 counties, including some very big names in healthcare, MD Anderson, Houston Methodist Hospital. Overall, they capture the healthcare activity of 70% of the doctors, 95% of the hospitals in this region. So organizationally, Greater Houston Health Connect would like to increase the value of this healthcare information exchange. Currently, it can be used to coordinate care across many different providers so that the single patient gets care that is informed no matter where they go within the area. But in addition, they could actually leverage this information that they have on the broad population and produce analytics that give indications of maybe latent diseases or latent conditions, things that people don't even know they have, or at the same time predict whether they're going to get better or worse based on their visits so far, based on their lab results so far. All this information is being collected mostly for doctors to review at the point of care. But we could also look at it with machine learning and perhaps develop a better prediction of a patient's health. So the way that we're going to go about seeing if this actually works with a proof of concept is we're looking at diabetes progression, disease progression. So someone might be pre-diabetic, but you really want to find out if they're getting worse or so bad that they're going to end up in the hospital and have a full-blown diagnosis of diabetes. In that way, you might be able to intervene early and help the patient get better lifestyle or get into a program where they help patients manage their disease. So that's the goal. It's still in flight, so we don't have any real results yet. But we're going to just test whether or not you can develop a better model using all of the data versus just using subsets of the data as maybe these member organizations might be able to do. And if we demonstrate that value, we would have a good case to go forward with providing more analytics services, increasing the value that Greater Houston Health Connect provides to the population. So physically, how this is being done, or architecturally, we have, as Greater Houston is a healthcare information exchange, they're a HealthShare customer. And a HealthShare instance is, a big server kind of application that is running in production. And you don't necessarily want to do machine learning right in your production environment. So we've set up a way that you can actually use mirroring to surface the tables and the information that are in the production system on the left and produce a sandbox environment on the right. So all of the health insight tables, which is the data warehouse that sits on top of HealthShare, those tables are available in the sandbox to be used for machine learning. Also in the sandbox environment is an enterprise on-premise installation of DataRobot. All of this is happening within a very secure environment. There is no data of anybody's going to the cloud. And the only people that are able to see this data and use this data are authorized to do so by the organization in accordance with all of the agreements that are made to keep this healthcare data safe and sound. So stay tuned. We'll have more information as that pilot progresses. But we'll go on now to looking into financial services. And this is a use case where we wanted to predict whether or not customers were going to make a large withdrawal, which they defined, the customer, which is a large retirement fund manager. They've defined it as 50% of the current balance of a customer's balance. If that's considered a large withdrawal, and they would like to be able to predict when those happen. So they provided, as part of this pilot, some data from 20,000 users, 2 years of data, and a limited number of fields. Actually, this is just not a heck of a lot of data about these customers to figure out a machine learning model to actually predict whether or not they're going to be withdrawing money. You can imagine someone's going to withdraw money and maybe switch to another provider of financial services retirement fund for any number of reasons. Maybe it's a job change. Who knows? So this wouldn't necessarily give you that data, but the data that they are giving might give some clues. There might be some patterns in their usage of in their other withdrawals that would indicate a big withdrawal is coming up. So of course there's some assumptions they used. We're trying to look at whether make sure that all the balance information is just about cash and not including stocks and bonds and other kinds of assets they might have. And of course, we have to make sure that users had both large and not large withdrawals. So prepared the data and created an integrated ML model on this. And then the idea was to look at different months of data and retrain with different months data to see how the model would work kind of in a production environment as it went forward. So this is how we can see a little bit of the syntax again, very simple syntax that was used to create the model for this actual real world use case. I think that's pretty impressive. So you have train model statement, validate, and querying the results. Very simple, just like I showed in the example. And here's some of the output that they got from that. As you can see, the actual large withdrawals that happen and the predicted are pretty close overall. Of course, you can see wide swings over on the right side. Those are users that are very old and there may not be any or very much data. And that's what happens with machine learning. If it hasn't had any data to train on, it's going to just guess. And so you can see some pretty wild guesses there on the right. So for our last use case, I'm going to hand this mic over to Minoru, and he's going to talk about a supply chain use case with the customer PALTAC. Go ahead.
Thank you, Tom. Hello, everyone. My name is Minoru Horita, a sales engineer at InterSystems Japan. Today, I'm going to talk about a machine learning POC at PALTAC, a long-term partner of InterSystems Japan, in a few slides. First of all, let me tell you a little about PALTAC, who they are, what they do. PALTAC is Japan's largest intermediate distributor. It's a wholesaler of daily necessities, over-the-counter pharmaceuticals, and cosmetic. If you see these numbers here, you will understand PALTAC is a very big company. As depicted in the pictures, wholesale business provides a great value to manufacturers and retailers, reducing the number of transactions costs, and it is key to the supply chain, whole entire supply chain. It enables businesses to deal with many different types of items in a small amount at a time. PALTAC is the largest player here and naturally has made huge investment in IT. We are partners for more than 30 years, and we are a major part of their IT investment. InterSystems technology has supported their critical business transactions with the super-fast database and the productive scripting language. Cache, our traditional database product, is used for the core of their business and also used for their applications for retailers that assist the retailers, such as demand forecasting. This is where the POC I'm talking about is targeted at. I will talk about this later. Also, they are very quick to adopt IRIS, our new product. Their field merchandising system is now running on IRIS. They also have plans to migrate other systems to IRIS, such as the main transactional system mentioned above. Now I'm going to talk about the POC, where IRIS plays a role of the data source for machine learning and connect to DataRobot's AutoML capabilities. Firstly, let's talk about some background. They face challenges in supporting retailers by providing more accurate information. For retailers, there is growing competition, especially among different types of stores. Drugstore sell foods and beverages nowadays, which competes with supermarkets and convenience store, etc. One of the social issues is food loss and waste to preserve the environment. Precise demand forecast will contribute not only to saving costs, but to supporting those social causes. These challenges has led to growing needs for more precise demand forecast. So what are they doing in the POC? Demand forecast for drugstores, which is PALTAC's client, is the target for this machine learning POC. They are aiming for 10% improvements in forecasting. They selected DataRobot for AutoML. AutoML is a popular technical term recently. PALTAC does not have dedicated data scientists, so utilizing AutoML would help them adopt machine learning in real-world scenarios. They are using 2 years of data from 30 stores, 30 SKUs per store for training out of 1,000 stores, 1,000 SKUs per store. Features. As you may know, features are data fed into the ML process, and features will be the basis for making predictions. Interesting one here is weather. They are planning to buy weather data from a major weather information services company. I think this is a good example of this data era. This is my slide, lessons learned. Actually, the POC is still in progress, so I should say there are lessons learned so far. But firstly, about ML and AutoML, it is very nice that they've got already 5% improvements with AutoML, which means without much of in-depth data science work. That really is the value of AutoML. But on the other hand, they experience some AutoML limitations. As depicted here, for example, zero sales can either mean there's no demand or the item is out of stock. This cannot be automatically detected, so they need to feed that information into the training process somehow. Even with AutoML, they found that everything cannot be trained automatically. Achieving more improvements like 5% to 10% requires data science knowledge, which generally is hard to acquire. Secondly, about the models, for demand forecast, what they call time series models are typically required. But the current version of IntegratedML does not support time series models. So they chose to use embedded Python, our new and powerful mechanism that tightly integrates Python runtime with IRIS runtime. Embedded Python enables them to directly access to IRIS database and to create Python data frames that are used for DataRobot interaction. This turns out to be a very powerful way to control the ML process with DataRobot. They really like it. When integrated ML supports time series models, we can offer more options. Quick and easy ML by integrated ML, and full and detailed control of the ML process by embedded Python. With embedded Python, they could develop Python code to automate the training process even more than with just using AutoML. I think this is very powerful and exciting. That's it for my part. So I'm going to pass over to Tom again. Thank you.
Thanks, Minoru. That's really cool. All right, so I'll talk a little bit now about where we're going with integrated ML. So overall, experience has been very good, but we want to do more. And so one of the first things, of course, that we're looking at is supporting time series, like Minoru was mentioning. So time series is kind of a different SQL pattern when you're doing the predictions, at least. And also, as part of the data input, you need to have some concept of like time when you're getting past events and when you're predicting future events. And time typically goes through multiple rows, either previous and forward rows. So you've got multiple columns, which could represent all your different products, and your multiple rows that are different time steps. And that needs to be supported natively by the SQL engine. So that's a little bit bigger project, but of course we would be supporting DataRobot's AutoTS, their auto time series machine learning capabilities, and we may add our own time series learning capabilities to the default AutoML provider. Another thing that we're looking at is really expanding the people, the roles, the personas, if you will, that will get value out of integrated ML. And we can make it extensible so that both developers and really experienced data scientists will be able to modify bits of the machine learning process, either using embedded Python, as Minoru mentioned, or some other mechanism, and maybe even allow developers to make their own providers, their own backends, because there's a world of machine learning packages out there, and not one package is going to do a good job on every single problem that you might have. Other things that we're looking at in the future is adding support for explanations. So there are a large number also of packages that will inspect your model and give an indication of which of the input variables were important for a given prediction, and for all the predictions that might be given to that might be gotten from the model. So that would be a new SQL kind of construct where you could pass any number of rows in for prediction and then get back a table that had columns for each of the contributions of the different input variables. So that would be very useful to then surface in your application to show some indication of why the machine learning model is making the prediction that it was. We also want to provide more capabilities for integrating with your machine learning ops and your overall application development lifecycle. So being able to export models from one instance of IRIS and import it into another instance of IRIS would really support this, our customers that have dev, staging, and production environments that they deliver their applications through. Another thing that we've seen would probably be useful is to make the train command asynchronous so that it returns immediately, and then we have some process management of being able to view what trainings are going on and be able to manage them, pause them, resume, stop, cancel them. And then we want to, of course, scale this to larger data sets. And also, there's a need for being able to manage your training and test data sets. Be able to say, split it in a percent, 80% for training, 20% for testing, and have InterSystems IRIS intelligently manage those data sets underneath. So that's all we have for today. I just wanted to recap what we talked about. We, of course, got an overview of what integrated ML is, and we talked about use cases in healthcare, financial services, and supply chain. Looked a little bit into the future of what integrated ML development is looking like. And I hope that you have learned a bit about not only what integrated ML can possibly provide for you, but also some of the use cases to get your juices flowing creatively about how you might use it in your own work. So, of course, if you have questions and want to find out more, reach out to your account manager. There's also a lot of information on Learning Services page at learning.intersystems.com. And I look forward to hearing from you myself. You can reach out to me by email or Minoru as well. And we really look forward to talking with you. So thanks very much. Appreciate it.